Welcome back, and welcome to section 3, where we're going to talk about S3 and CloudFront, two of the most popular storage and data distribution technologies available on AWS. In section 3, we're going to start with an introduction to S3, what it is, the performance available, the data consistency it offers, and some of the storage types offered. Next, we'll look at how to create an S3 bucket, something we've already briefly covered in the previous section, as well as how to upload some data to your S3 bucket. Next, we'll have a look in detail at some of the storage options available with S3 and the pricing implications of those storage options. We'll then move on to version control, the features that it offers, an overview of it, and some of the characteristics and benefits you get for applying version control policies to your S3 buckets. Next, we'll look at lifecycling, some of the automatic options available to transition data between the S3 storage options, and how we configure it. Then we'll move on to CloudFront, getting an understanding of what it is, how to use it, and when to use it, and what benefits it offers over purely accessing data that are stored directly in S3. Finally, a couple of more advanced topics: cores, access policies, and encryption. So if you're ready, let's get started. In this video, 3.1, Introduction to Amazon S3. So first of all, what is S3? Amazon S3 is a highly scalable, highly durable, object-based storage system. And what that means is it's purely designed for storing files. Conversely, when you think about a hard drive that's attached to your computer, that's actually what we call a block-based store, which means that you can actually use it to boot an operating system. S3 is not suitable for that kind of use case. It's simply designed for uploading and storing files or data blobs. Amazon S3 provides a simple web interface to store and retrieve any amount of data, and that really is the goal here, to have low cost, infinitely scalable, very fast, easily accessible storage in the cloud. And in terms of payment, you simply pay for what you use. Amazon charge, at the last count, 5 cents per gigabyte of data uploaded, and you get charged an additional fee for the amount of data that you download. So Amazon S3 is a simple key-based object store. So think about this in terms of files. Every object that you upload to Amazon S3 has a key, and that's the file name, and the object, which is the data, which is just a binary blob. And objects can be sized anywhere between 0 bytes and 5 terabytes. And you can have an unlimited number of objects in a single bucket. Slight caveat, if you have an object that's greater than 5 gigabytes, you have to use what's called the multi-part upload API and the complete multi-part upload API to confirm the data is fully uploaded. But you can actually store objects that are as large as 5 terabytes in one go. If you have objects that are larger than that, you simply need to split them into multiple chunks and use your application to keep track of where those chunks are. And as you might expect, it offers a simple HTTP-based REST API, and you receive a 200 response code for a successful upload. As I've mentioned before, files are stored in units called buckets. You can have, by default, up to 100 buckets per AWS account, although this can be increased by opening a ticket with support. And bucket names must be unique globally within a region. Bucket names are typically DNS compatible. So if you look at the link here, https://regionname.amazonaws.com/bucket name, your bucket name needs to be a DNS compatible name. And the reason for that is because you can actually use your bucket to host a website. So think of it as running its own Apache HTTP server in the background. You can upload your static web files and have them hosted directly out of your Amazon S3 bucket, which is quite a cool feature. Now, buckets are regional, which means if you upload data to the island region, it stays in the island region. However, there's no guarantee which availability zone the data will stay in. Amazon offers, I think it's 7 nines redundancy on your data, so there will be multiple copies of your data stored in all of the availability zones within a given region. However, if you want to transfer the data between regions, you have to explicitly request this. So if you're complying to some data privacy laws, and you explicitly upload your data into a given region, you can be sure that the data will remain in that region unless you move it. In terms of data consistency, Amazon offers read after write consistency for puts of all new objects. So that means that after a write has completed, you know that all reads will be consistent for that write. And you get eventual consistency for overwrite puts and deletes. So that means there may be a slight delay from after you've updated an object or overwritten an object or deleted it to when the read will come back as showing that operation having completed. So for example, if you upload an image, as soon as that image is uploaded, it's immediately available to be read. However, if you do a put operation on that image to update it, some reads may still show the old image for a certain amount of time, and this is what we call eventual consistency. And the same behavior is exhibited for deletes. In terms of request wait performance, Amazon S3 will scale automatically to support a very, very high number of request waits, up to 800 GET requests per second without opening a support ticket with AWS. If you plan to scale beyond 800 GETs per second or more than 300 puts and deletes per second, you should open a support case with AWS. The reason for this is Amazon want to restrict you from entering a situation where you have extremely high billing. So for example, if you upload a file and it becomes very popular, if you share the link around the internet or a video that you share around the internet, Amazon will throttle the number of requests to that object to 800 per second. And that's just a temporary limitation purely to restrict you from going over the top on bills, but also to protect their infrastructure. Of course, if you require more throughput than that, you simply open a support ticket and Amazon will sort it out for you in the back end. In order to ensure consistent performance, however, Amazon recommend that you don't scale beyond 300 GET requests per second or 100 put list or delete requests per second for a single bucket. Again, you can scale beyond this, but in order to do so, you should open a ticket with Amazon before attempting to release an application that has this kind of bandwidth requirement. In terms of other best practices, when you're getting a lot of data or performing a lot of GET requests, it makes sense to use Amazon CloudFront as a cache for S3 objects, and this will allow your users to have much lower latency and a much higher data transfer rate when pulling objects from S3. And the reason for this, as we mentioned before, is CloudFront is a content distribution network, which means it moves your objects and your data closer to the users to ensure optimal performance. So that's everything I wanted to talk about on Amazon S3.